In part 3, we described the half-wave rectifier, which used one diode. In this part 4, we're going to discuss a full-wave rectifier and how to implement it with 4 diodes. Recall that in the half-wave rectifier, the load saw only the positive part of the sinusoidal waveform. And what we'd like to do is take that circuit, which had one diode, and use the basic idea of the diode as a switch to come up with a circuit that lets us look at the entire waveform. And here's the clever part. We're going to flip the negative part of the supply waveform positive. And to do that, we're going to be using 4 diodes. Let's start by looking at what the desired waveform should be. Here's our input waveform. And in this case, our output waveform not only should reproduce the positive parts of the waveform, but flip the negative part positive. So this is where we use our bridge, and if you recall, when we looked at the generalized bridge, we used switches. So in this case, our diodes are going to become those switches. Let's draw the circuit. I have 4 diodes. And notice the direction that I'm drawing these diodes. It's very important to get the polarity right. So to summarize real quickly, this diode here is going to only allow flow in this direction. This diode will only allow flow in this direction. This diode will only allow flow in this direction, and similarly for this one. Let's connect our power supply and our ground. And finally, let's bridge these 2 parallel branches with our load. Now, look what happens. Let's look at the case of the positive part of the waveform. In that case, we'll have a positive voltage between the supply and ground, and that means that these 2 diodes will look like wires. So the current will flow like this, from left to right across the load. Now, let's look at the case where the supply voltage is negative. That means that current wants to flow from ground up to supply, in other words, in the opposite direction. No problem. In that case, the current is going to flow through this diode, through the load from left to right, through this diode, and out this way. And that's the case where we are flipping from a negative swing to a positive swing. Now this is very interesting because we now have a circuit in which we've gone from 1 diode to 4 diodes, but we've doubled the efficiency of our system. And that's because now all the negative swings of the waveform are converted to positive swings that the load can use. In part 5 of this module, we are going to move onward to inversion, or the conversion of DC power to AC power.